All right, section 6.4 is transformation of exponential and logarithmic functions. Remember, today we're going to do transformation of exponential functions, and then tomorrow we'll go ahead and do logarithmic functions. So remember, you can transform graphs of exponential functions just like previous functions, like we did in chapter 5 and chapter 4, all the other ones. We had this same kind of list, ladies and gentlemen, all right? So in this one here, for the example that they have here, they're going to say let f of x equal 4 raised to the x power. So on this one here, again, if you think about it, when we have x plus h or x minus h, it's always going to be the opposite. So since I have a minus 3 here, it goes right. I have a plus 2 here, it goes left. So that means it's going this way, all right? When it's a vertical, and again, notice it's inside the parentheses there. I keep hinting inside x, outside y. If you're not really sure what happens, if it's on the top there, put parentheses around it and see what you do, okay? Vertical translation, it shifts it up or down. That's k, all right? The one that's different is the reflection. Remember, if it's attached to the x, it's going to go over the y-axis. If it's attached to the outside here, it's going to go over the x-axis, all right? And then a horizontal stretch and shrink, remember, that's what I always tell you. You hear the word horizontal, you are going to take the opposite or the reciprocal. So on this one here, I have 2x, and you can see it shrinks by 1/2. This one here, I have x divided by 2. That means it's going to be a stretch by 2. Again, we're flipping it. And when it's a vertical stretch or shrink, again, it's going to be on the outside here. In this case, it's with the number. And again, we're going to put parentheses around our 4 raised to the x power there, because remember, I can't just multiply them and say it's 12 raised to the x power. That doesn't work at all. All right, so let's do 3 examples here, ladies and gentlemen, and you should be on your way. So, number 1, describe the transformation of f of x is equal to 1/3 raised to the x power, represented by g of x, which is 1/3 raised to the x power minus 5. And then it wants us to graph the function. So if we look here, we have, how can I write that? I have 1/3 raised to the x power. I don't have an h width there, but I do have a plus k. So in this case, my k is -5. And that means what I'm going to do is I'm going to go down 5. Since I'm going to go down 5, one of the easiest things to do, ladies and gentlemen, is again, well, let's go ahead and graph our function here. So remember, anything raised to the 0 power is 1. So when x is equal to 0, y is equal to 1. When x is equal to 1, it's going to be 1/3. And remember, when it's to the negative first power, we're kind of flipping it again. So when it's at 1, it's going to be 1, 2, 3. And again, we notice that it is going down quickly. And then remember, our y is equal to 0, or our x-axis is our asymptote. All right? So when we do our next one here, okay, one of the things that you can see is if I'm going to go 5 down, even my asymptote is going to go 5 down. So I can easily go from here, go 1, 2, 3, 4, 5. And there's my new asymptote. And at my asymptote there, it is at y is equal to -5. So it went down. But now, just kind of think of what you did on the other one, and it should still work fine on this example. So on the last one, remember, I went up 1 from 0. I will do the same thing. All right? I'm going to get, when it's at 1, I'm going to get it at 1/3 there. And when it's at -1, it's at 3. So again, I'm just treating my y is equal to -5 as my y is equal to 0. And I still have the same type of function. Okay? So if I do that, then I have this right here. And again, that's our G. And let's see here, I should put my F here. So that was my F of X. Okay, so just think about stuff like that and it should help. Okay, and you can always plug it in your calculator to make sure it's right. Remember, you can do both of them on Desmos there if you want. Okay, so our next example, describe the transformation of F of X is equal to E raised to the X power, represented by G of X, is equal to E raised to the X plus 2 power minus 1. So remember, what we have to remember is our general formula would be E raised to the X plus H minus K. Plus K minus H, excuse me. All right, so E raised to the X minus H plus K. If we look at the one we have here, we have X plus 2. So remember, how am I going to write X minus H as X plus 2? Well, wouldn't that be X minus a negative 2? All right, so we're saying then that H is equal to negative 2. And remember, what is that going to do? That's going to shift it left or right. Which one is it going to shift it? Hopefully you'll remember. If you're not sure, go up here. Okay, which way is it going to shift it? It's going to shift it, since it's plus 2 there, it's going to shift it to the right. Okay, but just remember H is equal to negative 2. All right, so that means we're going to go 2 left. And our K is minus 1. So that tells us we're going to go 1 down. All right. So on our first one here, we're going to say this was at 0 and 1. Remember, when it was at 1, it's like 2.7. And on this one, it's going to be real close. And so that is the way our function should look. And that would be our F. Okay. So now on this one here, I want you to kind of think, and an easy way to do this would be to choose a point. All right. So if I take my point there, okay, now first of all, I should probably tell you this. Where's our new asymptote going to be? Our new asymptote is going to be here, right? Because it's 1 down. So this is our y is equal to negative 1. That's our new asymptote. But now, I want you to kind of think here. Why don't you take a point and do exactly what we said and then go from there? So if I take this point here, all right, I'm going to go, it says 2 left, excuse me. I'm going to go 2 left, 1, 2, and I'm going to go 1 down. All right, so now, does that make sense to you? I should hope so, because again, if it didn't, it did go up 1, right? So on this one here, we went up 1, and then we're going up 1 right there. So it does work, ladies and gentlemen. So again, kind of do the same thing like I just told you. So we're going to make that one here. So that's our new one. Okay. And then our, if we do, if we go 1, remember, so when we went over 1 this way, we went up 2.7. So if we go here, we go over 1. Again, notice I'm going from my new asymptote. So I'm going from my new asymptote there. So I'm going to go over 1, and I'm going to go up 1 to 2.75. It's going to be right there. And then remember at negative 1, just think you're just using the same thing. It's just different numbers. And right now, you don't need to really know about what the number is exactly. You can always plug it in. But they're just asking you to draw a graph. All right? So that should help on that one. Again, remember the asymptote can change. Sometimes it can. So on this last example here, describe the transformation of F represented by G. And then, then graph each function. So F of X is 2 raised to the x power, and g of x is equal to 2 times 2 raised to the 2 times x minus 4. Okay, so on this one here, remember, it's going to say 2, and then we have 2. Well, not 2, excuse me. I just want to give you the general formula, right? So we're going to say it's a times x minus 4. Or, excuse me, well, let's go ahead and again, I'm giving you the formula, so it's minus h. So in this case here, our a is equal to 2, and our h is equal to, again, if we look at it, they're both negative, so our h is equal to 4. All right, so then what that is going to tell us, we have 4 right, and let me go ahead and graph the first one here. All right, so again, on the first one here, when it's x is equal to 0, again, anything raised to the 0 power is equal to 1. When I'm at 1, 2 raised to the first power is 2. Remember, if it was at 2, it'd be at 4. And you're going to keep going up. And again, if it's at negative 1, it's going to be at 1/2. So you're going to have one that looks like that. And again, our asymptote is y is equal to 0. On our other one, it's also going to be y is equal to 0 because we have no k over here, right? So we're going to say 4 right. Okay, so I'm going to go back to red so I can graph that one. That's going to give us what? So the one in front, that's going to give us a horizontal or a vertical. Remember, it's going to be a horizontal shrink of 1/2 of the graph of f. And in this case, remember, our f is 2 raised to the x power. So what I want you to think here, and this is what's going to help you, it's a horizontal shrink. So if you think about it, they're telling me to go over 1, 2, 3, 4. They're telling me to go here, all right? But now remember, on this here, it's going to shrink towards the y-axis. And that means I'm going to take 1/2 of 4, which is going to equal 2. So that's kind of why that one goes there. Okay. And if you want to think about it, it's also kind of telling you the same thing up here. All right. I would have 2. And if I put in this in right here like that, remember, I'm going to go over 4, which I just did. But then that 2, again, that's what's going to make it go 1/2, because again, it's still attached there. I know I'm making a big mess there, but just think of it. If you want to put the original dot there and then take half of that in this case, and then go from there. So that's that one there. Okay, and then we would have gone 1 and 1, and then this one is right here. So they're kind of, and remember, we didn't change anything, so our asymptote is the same. There's our G. Let's go ahead and name our F. And that's it. Hopefully that helped you, ladies and gentlemen. Thank you.